Hello. Hi, I'm Colin. I'm the architect at Dataloop. Today I'm going to kind of give a brief overview of the time series database we built, how we built it, and why. Okay, so we've got three core components to Dataloop. Can everyone? Okay. Right, so yeah, we've got three core components to Dataloop. We've got the collection component. So we have a Python agent which runs on the nodes and will return Nagios format metrics back to our system. We also expose a Graphite and StatsD port. So your Graphite client like CollectD and StatsD can spit metrics directly into our system, which ends up generating quite a bit of load. The second part is storage. So we've got all of these metrics fire into our system. We need to persist them, right, so that you can kind of query them, see what's going on. So yeah, we persist those, and we have like a query API on top of that. And then the third part is the analytics. So yeah, we've got all this data. Users want to kind of see what's going on so they can get some insight into their system, kind of view graphs, etc. Yeah, so this part we're going to kind of go into the storage component. So how we built our time series database, and yeah, how it works. So yeah, we had a couple of attempts at doing this. When we first started, we were using a service called TempoDB. So it was okay, you could fire metrics in, run some queries. It sort of worked, and then one night it stopped working. We don't really know why. We think they had some kind of outage. So we were getting some metrics go in. We're getting some really funny behavior. I wasn't confident in the system. And yeah, that night we had a kind of complete outage, and we happened to have a demo the next day. So I kind of quickly had to change our backend to fire the metrics into the existing MongoDB cluster we had. Which moves us on to the next point. MongoDB was kind of our savior. It kind of saved us for a couple of weeks. But Mongo's great. It's kind of really flexible. You can get up and going quite quickly. But then when you throw any kind of write load at it, it kind of just explodes. So we knew this was a kind of a short-term solution. We'd have to kind of come up with a better way of solving this problem. So React was our new hope. It kind of it gave us a way of solving this issue. So React's great. It scales. You start hitting a massive amount of load. You've got a lot of disk space being taken up. You can just start adding boxes in there, and it'll grow horizontally. Obviously, there are other solutions we've looked at which do this as well. HBase, Cassandra, OpenTSDB. They weren't quite as flexible as what we wanted. We have some other plans coming up in the future, so we decided to kind of build our own on top of that. We decided to go with React because, it scales, it's ops friendly. If it kind of crashes and dies, it kind of handles that for you. You don't get woken up for, just a single box going down in your 5-node cluster. It actually works. So it's written on Erlang. I don't know if this is just an Erlang thing, but stuff written in Erlang just seems to work. We use RabbitMQ, which is awesome. That's never kind of caused us any issues. And yeah, I kind of got a bugbear with the JVM because it always tends to crash on me. Okay, so we decided we were going to build this system. We kind of outlined some high-level objectives for what we wanted to get out of it. So the first one was we need to handle all this load. We need to handle all these metrics that are coming in. Obviously, building a monitoring tool, even at quite low scale without many customers, you've still got a lot of metrics coming in. So, and that's only going to get exponentially worse, right? So yeah, we need to handle all that load. We also want to run kind of semi-arbitrary queries against the data. So, you want to see kind of a particular time range for a particular collection of nodes on a particular range of metrics. So we need to keep that in mind. We also wanted to have defined data retention periods. So, for like free customers, we would want it to be able to expire the data after 24 hours, or we wanted to kind of roll the resolutions of data along so that we weren't storing second-level resolution data indefinitely, because that would kind of kill us. Low latency also. So we wanted to get the data from the host visible in the client within a couple of seconds, right? If you're debugging an issue, you don't want 30 seconds to a minute before you can actually see what's going on, to see it in your graph. So they were sort of the 4 objectives really we had. Yeah, so we kind of looked at this and tried to kind of work out how we were going to structure the data, how we were going to put it into React. So we knew we wanted to have to do resolution-based queries. So if you're querying across a whole year, you don't really want second-level data because it will take ages to pull that down. So we kind of we decided to go with second, minute, and hour-based resolutions. And we knew that we wanted to keep at least 24 hours worth of second-level data. So you can pinpoint within that 24 hours exactly what was going on at a particular point in time. So for 24 hours at second-level data, that works out at 86,400 data points, obviously. So that kind of fit in well with the other resolutions we wanted to keep. So at a minute, that number of data points allows us to keep the data for 60 days. And then obviously moving to the hour, it's around 10 years. But yeah, by the time we get to 10 years, who knows what's going on. We'll probably just keep it forever. Sorry, my slides have gone mental. Okay, so initial kind of, well, these weren't really our thoughts, but to begin with, we're kind of thinking maybe we could just fire these in metric per key, and just store them as they come in. That would have caused us quite some issues. So we'd have had quite a lot of load coming in on React. So if you're writing, trying to write, 10,000 keys per second to React, it's soon going to blow up the cluster. Also, then querying the data back out. The kind of documentation of IG2 secondary indexes or MapReduce queries, they were kind of too slow, really, for what we needed. Especially if you get into the millions and billions worth of keys. So we kind of threw this simple solution out the window. And then we kind of decided to go with a less intensive approach. So as data is coming in, we kind of build up time-based blocks of data. So we all kind of roll the metrics up into blocks and then write them into React. So say we might store a block of about an hour's worth of data. So then that gets stored into data, and we compute the keys for that data based on the time-based bounds. So if you're storing an hour's worth of data, you'll key that off of the epoch for the start of that particular hour. Does that make sense? That allowed us to significantly reduce the amount of data we were writing into React and allowed us to pull the data back out again. We also have these mutable data windows. So we wrote this pre-React 2. So if you have two processes running and you end up with a write conflict, so you both start writing to the same key at the same time, React has two solutions to this. So the first one, the default, is that it will last write wins. So you'll end up blatting over some data you've got there. You can change it so that it will produce siblings, and so that it will keep both of them. And the next time you pull the data out, you have to merge those and then push the actual correct values back in. We didn't really want to deal with that issue, and we kind of found a better way. So we have mutable data windows. So we store several seconds worth of data, and we will write that in one massive chunk into React. So we reduce the chances of you getting a write conflict, because it's only one block getting written at a time for a particular metric. Okay, so we've got all this data in. We really need to be able to pull it out, right? So because we've pre-computed our keys and we're storing in these specific blocks, say you wanted to pull out all your CPU metrics for a particular host between a specific time range. It's relatively simple to do. So you work out the actual key block boundaries for those data points. So you want a particular hours, you work out the hour boundaries for those, and then you pull the React keys in. You pull the React data out of React. And these are some examples, some keys here. So we're pulling the CPU, we've got second level resolution, and then we're pulling the time boundaries, so the start of those particular time boundaries. We pull those in, and then obviously you might be querying between the kind of middle of a block boundary, so you might want like halfway between an hour or halfway between whatever the boundary is, whatever the block size is. So we kind of pull those in, and then we run a quick filter query over that. That gets rid of any stuff that is outside of the range, and then we aggregate all the data points together. And then, if you've got a more complex query, maybe you want to kind of aggregate the average across a certain collection of metrics. Then you can run additional roll-ups and aggregation over the top of that. And yeah, that's all in memory, so it's really pretty quick. Expiring. So yeah, we've got all this data coming in. If you, we don't, ideally want to keep it all, but it's not always possible. So we know we're going to keep at least 24 hours worth of second level metrics. And because we've computed our keys based off of host and based off of the time block boundaries, we have a simple cleanup worker that runs in the background, and we'll look up keys and check whether their retention period is out and is timed out, and then if it has, we expire them. At the moment, that means deleting them, but obviously in future we could put them into cold storage and then maybe do some data mining on it at some point. Also, yeah, because we're keying them off of the particular host, because we data loops designed so that you can quickly, sorry, moving the mic, so that you can quickly bring up and down boxes, scale your system. You'll be adding nodes and then dropping them off again. So you want to be able to get rid of that data that's no longer needed. Because they're keyed off of host, we can quickly just scan through a whole bucket and just drop the bucket. Again, it's a little bit of load on React, but it's not so bad. And then obviously if accounts expire, people leave, we can kind of get rid of their data. Because when we looked into this, we looked at how hosted graphite use React, and they were kind of saying about the issues they had with basically getting rid of the data and handling all that's coming in. So we kind of thought about that beforehand. So yeah, as a quick overview of the cluster we use. We're actually running on React 2.0, even though it's not generally available yet. We've been informed that it's pretty much solid, and it's been great so far. We have a 5-node React cluster running on top of LevelDB. If you're not familiar with React, there's several backends that you can have running. So the default one is Bitcast. So it still writes to disk, but it tends to keep everything in memory, which is great, and you get some certain advantages with that. But we don't know how big this thing is going to grow, so we don't want to end up blowing our cluster because we can't keep all of the keys in memory. Yeah, we have 2 half-terabyte striped SSDs running on the box. We went with striped because who cares if a disk dies, we just drop it out and then bring it back into the cluster. And then, yeah, our latencies. So the latencies on React we got are sub 1 millisecond at the moment. It's just amazingly quick. This is I don't know if you can see that. It's a bit small to try and get it all into the screen, but these are some of the averages we've got for puts and gets into React. So our 99 percentiles are running kind of either below or in the kind of teens of milliseconds. And then our means are 1 millisecond. It's just crazily quick. Yeah, so React, great for ops. So need to scale, just drop a box in there, add it to the cluster, automatically balance the keys across the cluster. It's a bit more work for the developer. As I say, we kind of have to compute our keys. We don't keep everything inside React. It's only time series data at the moment. It's an option that we can kind of get rid of our Mongo box and kind of move everything to React, but then there's, having to do extra indexes and stuff on top of that. Yeah, try and compute your keys where possible. We do use some 2i and MapReduce for slow background tasks, but if you need kind of instant response, they're not great really. And then yeah, because we're on React 2, it's got some great new features for handling concurrent writes. So there's different types of buckets that are available so that you can, it will handle having concurrent writes coming in, and it will do the merges and make sure you don't kind of end up corrupting the data you've got. And yeah, that's pretty much it.